Okay, hello everyone. Today what we're going to do is I will go over the quiz. My idea today is actually to recap what Professor Susita did kind of quickly. And next time we'll start definitely new material. So today I will somehow kind of go over problems and explain a little bit more what happened the last week. And in the meantime, if you have questions, you guys can put them on the chat for me, okay? So as I promised some of you, I will go through problem number 1 on the quiz, and 2 will come later. Number 2, I will have to explain some things a little bit more. So the first problem was, you did well. I don't have much to complain about except part C. That's where you guys had difficulties. So we had a function, which is a typical quadratic function. And the question is answer the following about the function. So find the coordinate of the vertex. So the graph here is a parabola. The A is 1. The B is 10. And the C is minus 12. Okay, and find the coordinate. So we've learned the formula for the coordinate. The x coordinate is minus b over 2a. So in this case, it's going to be minus 10 over 2, which is 5. So that's the x coordinate. So the x coordinate is right here at minus 5. Now the y coordinate, you just plug in minus 5 for that, plus 10, minus 12, and you got minus 35. So most of you as a whole got that part right. So this is minus 35, that's my vertex. And this is a parabola going up. So the graph of the parabola is like this. So that's the parabola. That's the graph. And minus 12 is actually right here, because minus 12 is when x is 0, that's really minus 12. So that's the first question. The second is find the zeros. So you said this equal to 0. So in this question, what we're asking for are basically this point right here and this point right here. That's really what the question is, all right? So determine the zeros. So we tried to factor here. Of course, you couldn't factor. When you cannot factor, you have to apply the quadratic formula. And all of you did that, most of you actually. So we have to use the quadratic here. And the quadratic tells me we have 2 values. One is the minus b plus or minus the b squared minus 4ac, which was turned out to be 48 divided by 2a. And the other, that's plus, sorry, that's the plus one. And the other one was minus 10 minus the square root of that over 2. Okay, that was really the idea. And the 148, it was actually 4 times 37 over 2. And this really made us, help us to simplify this tiny bit. And this gave me minus 2 plus 2 times the square root of 37 over 2. And we factored out the 2 in the numerator. We got minus 5 plus this over 2, which gave us minus 5 plus the square root of 37. Okay, I would be happy if you guys stop here, not even evaluate it. I really would, yeah, I'm better, Dakota. So now the other one was minus 5 minus the square root of 37. Okay, so because we couldn't factor quadratic. Now the problem a lot of you had was this question, and actually you don't really know why you had difficulties with this question. The question is find the value of d where the function takes the value minus 12. In this problem, minus 12 is the output value. So basically, this is minus 12. And my question is, which input give you an output of minus 12? That's really what my question is. According to my picture, there are two values which will give you minus 12. And my question is, where are they? So in this particular problem, it means you set the function. Now don't let the d bother you. Minus 12 equal to minus 12 and solve for d. That's really what you have to do. A lot of you plugged in minus 12 into the formula. It's wrong. I did not ask about f of minus 12. If the question was find f of minus 12, you plug in minus 12 here. What I ask is, what's the input that gives you an output of minus 12? Now you have to solve. That's a quadratic. The best way to solve is somehow to create a zero here. To create a zero, we need to add 12 both sides. And this would give me d squared plus 10d minus 12 plus 12. It means d squared plus 10d equal to 0. Now solving is factoring. And if we cannot factor, we use a quadratic. But here, we can factor because I get a d times d plus 10 equal to 0. Okay, so this will give me either d equal to 0 or d equal minus 10. And of the problem. So that's really the one that you guys, yes, maybe the letter D, you're right. That's what I thought. But you know, you have to get used to different letters. I don't have to put X all the time. So that's the part that's what I thought. You're right. So that's really the part you guys somehow messed up with. So this is basically the minus 10, and this is the 0. Okay, so that's really we'll get for the quiz. So be very careful what's the ask, what is really given to you. And that's what happened in this problem. Number 2, I'm going to talk about it right now. So for number 2, I will need to, sorry. Okay. For number 2, I actually need to do some explanation and then I will go back to number 2. So I would like to talk a little bit about this percent rate. I know that Professor Sita talked about it, but I would like to talk a little bit more about it. Okay. So now back to exponential. And exponential functions. So they are functions that has written in this form. And this, I talked about it before I left you guys, a times b to the x. And x, they're called exponential because the input is an exponent. So that's the form of the exponential function. A is called the initial value because if we evaluate the function at 0, we get that. Anything to the power 0 is 1, we get A. So it means when we graph the function, this is, and B is called the growth factor. Okay, so that's what an exponential function looks. That's what an exponential function, the formula for it. Now the question is, how do they arrive in real problems? And that's really what your quiz was about. So how do exponential functions arise in real problems? So now you have to be a little bit patient with me so I can explain this idea clearly. Okay, that's my scenario. Suppose a person is hired at a salary of $40,000 and receives a 6% raise every year. And assume the raise continue for several years. So somebody is lucky, he got hired for $40,000 and every year, you know, he's gonna get a raise of 60%, 6% raise. Let f of t be the salary of the person t years after they were hired. Okay, and my question is, what is f of 0? What is f of 1? And that's f of 2. So that's really my scenario. 40,000, every year you get 6% of your new income. So your income is really going to increase. So that's find f of 0, f of 1, f of 2. Okay. So you guys help me out. You guys have a calculator and everything. What is f of 0? I want answers immediately, because I have to cover a lot of material to get going. What is f of 0? F of t is the salary of the person t years after they were hired. So f of 0 is 4,000. Every time we have a value, I will here graph it. So that's the time, and that's f of t. Okay. Initially, it was 40,000. That's how much she started. Now the question is, what is f of 1? Means after 1 year. Okay. So let us say he started January 1st, 2020. He got a raise after 1 year. So January 1st, 2000, whatever. 2000, what did I say? 2000, January 1st, 2001. What's going to be his income? Exactly. It's the 40,000, what he made, plus the 6%. Now, 6%, to get the 6% of something, it's just 6 over 100. It means 0.06. So plus 0.06 of his income. That's so in 1 year, that was the increase. And you guys are giving me the correct answer. It's going to be 42,400. So after 1 year, back to my picture, after 1 year, the income increased. Increased by how much? So that's after 1 year. From here to here, the increase was the 6% of the 40,000. So that's the 40,400, and increased by 6%. Okay. Now, keep going. After 2 years, what is his income? So by now, his income is 42,000. After 2 years, his income is going to be 42,000, what he had the year before, but then he's going to get 6% of the 42,000. So this time he's going to get 6% of what he had. And you guys are giving me the answers. So if I just pick up my calculator, 44,944. So in the picture, what happened after 2 years? Does his income going to increase by the same amount between 0 and 1, or by more than that? Or by more? Absolutely more, because right now we have his income is going to increase by 6% of his new salary. Okay, so it's not definitely not a linear. It's not increasing by the same amount. The function is definitely not linear, because every year it's not increasing by the same amount. This is not a linear function. It's what we're going to happen, what we're going to call an exponential function. So now I need to find a formula for this. To find a formula, so my second question is find a formula for f of t. Now, as we watch what's happening clearly, there is a pattern that's showing up. Initially 40. After 1 year is what he made, plus 6% of what he made. I got that. A year later was what he had the year before, plus 6% of what he had the year before. So one way we can think about it is the following. After 1 year, he had 100% of what he had before. So it's the 100% of the 40 plus 6% of 40. So we're going to think a little bit about it this way. So after 1 year, his income was 100% of 40, all of it, plus the 6%. So his income was 106% of the 40,000. So after 1 year, his income was 106% of 40. But 106% is how much? 106% is 106 over the 100, which is 1.06. So it's 1.06 times the 40,000. So after 1 year, his income is 106% of 40,000, or 1.06 times 40. Does this pattern continue? Watch here. How much he had after 2 years. It's what he had the year before. Again, it means 100% of his previous income. And that's crucial to come up with the formula. Plus the 6% of his previous income. So he had income is 106% of what he had the year before. In other words, is 1.06 times what he had the year before. So there is a pattern. So after 1 year, his income is, you can compute it this way, or you can say it's 106% of 40. It means 1.06 times 40. After 2 years, it's either you compute it this way or you say no, it's 106% of what he had the year before. It means 1.06 times 42,400. And this comment is going to help us actually figuring out the formula. So what's the formula for f of t? Every year, his new salary, his old salary, mean the salary of the previous year. That's what's happening every year. Plus 6% of his old salary, or 6% of his salary the previous year. So every year, that's what's happening to his salary. His salary is 106% of the salary in the previous year. So every year, what's his income? 106% of what he made, because he's adding 6% every year. Okay, let us make a small table now and understand the picture. So, or if you want, it's 1.06 times salary of previous year. Okay. And now this should explain everything. So let us make a table and understand the picture. This is t, and this is f of t. At equal to 0, we had 40,000. After 1 year, what did we have? We had we had 40,000, but 106% times 1.06. That's what he had after 1 year. It's the 100% plus the 6%. After 2 years, how much he had? What he had the previous year. So that's what he had the previous year. But times how much? Times how much? Are you guys with me or you lost me? Are you losing me? Okay, times how much? After 2 years, what times 1.06. Every year, his income is what it was the year before times 1.06. After 2 years, what's his income? What it was the year before, whatever this number is, I don't want to compute it, but because I want to reach a pattern, times the 1.06. So it's 106% of what he had the year before. Now, a little bit of math tells me that this is 40,000 times, if I multiply those two, I get 1.06 squared. So what is the pattern? From 1 year to another, his income is multiplied by 1.06. That's really. From here to here, his income is multiplied by 1.06. So from 1 year to another, we're multiplying by 1.06. So after 3 years, that's what's happening. What's his income? What he made the previous year, and I think we're done now almost. What he made the previous year times the 1.06. So it's 106% of what he made the previous year. I combine those exponents and I get the 40,000 times 1.06 to the power 3. So that's really the pattern. So every year we multiply the previous year by 1.06. Every year we multiply the previous by 1.06. Every year multiply the previous by 1.06. So at time t, in general, so the formula is going to be 40,000 times 1.06 to the power t. So after 3 years to the power 3. After 4 years, I multiply by another 1.06. When I get 1.06 to the power 4, and so on and so forth. So that's how much you will have after t years. So that's the initial amount. And the 1.06 is represent the 106%. That's really where the 1.06 to the power t comes from. So the formula now for f of t is going to be the initial value times 1.06 to the power 2. So that's really what's happening. That's the exponential function. That's really what the exponential function really coming from. It's something that's grow by the same percent every unit of time, by the same percent, 6%, 2%, 3%. That's really what the exponential function coming from. So let me sum up a little bit here and do the terminology. The 6% is called the growth rate. It's called the growth rate or percent growth rate. So some books call it the percent growth rate, or sometimes some books drop the percent and use growth rate. But it's the percent. It's by how much, by what percent the quantity is increasing per unit of time. And in the formula, f of t equal 40,000 times 1 plus 0.6. The b here, so that's definitely an exponential growth. The b is the 1.06. The b is called the growth factor. The b is called the growth factor. And what is the growth factor? So if I have a quantity that's increasing by the same percent, the growth... Sorry, I have to remove this phone from the room. Apologize for that. So the 1.06 is coming from, it's the 1, which represents the 100%, plus the 0.06, which is the growth rate. So that's the B, is called the growth factor, which is 1 plus the growth rate. Okay, so that's really what happened when we have an increase by 6%. So my second question is, what if you have something that is decreasing by the same percent? What will be the picture? So now we can go through that a little bit quicker. So example number 2. Suppose we have the following problem. In a certain town, the population was 20,000. Big deal. I'm making up numbers. In 2010. And it is decreasing by 3% per year. So now we're losing 3% every year. Every year we lose 3%. Find a formula for the population T years after 2010. So what's gonna change in this picture? What's gonna change in here? And what's gonna be the formula? Okay, first, in this problem, because the population is decreasing, we say that the population is changing by -3% per year. So that's the language the book is using. And we say that the growth rate is -3%. So the minus here represent the idea that the population is decreasing by 3%. But the question is, what's the formula? We're gonna work almost the same idea I did a minute before to find the formula. So what's gonna be the formula here? So let's analyze what's happening every year for the population. So each year, what's the new population? Remember, every year is decreasing by, is going down by 3%. Exactly, but how are we gonna write this mathematically? Every year, the new population is, very good, 97%. It's 100% of the old population minus 3% of the old population. So every time it's 100% minus 3%. It means it's 97% of the old population. So every year the population is 97% of the year before it. Every year is 97%. It means every year is 0.97 times the population of the year before it. So every time we multiply this time by 0.97. Where is the 0.97 coming from? Is the 100% minus the 3%. So every time is 97% of what it was. So the formula now is going to be verbatim, using the same logic, at every time t, the population is going to be what it started with times 0.97 to the power t. That's how the population would be. And now let us one more time analyze the 0.97. So B, which is the growth factor, is 0.97. But where is the 0.97 coming from? It's the 1, which represented the 100%, minus the 0.3. Or it's 1 plus the minus 0.3. So it means the growth factor, which is the B, is always 1 plus the growth rate. In this case, the growth rate is -3, minus 0.3. So which is going to give me the 0.97. So that's really what is, that's where exponential function really comes from. That's really the idea. It's something that increase or decrease by the same percent. We have to be very careful. What goes in here is not the 3%. What goes in here is the growth factor. It means 1 minus the 3%. We have to be very careful with my B. So let us summarize what I am talking about, and then I go through the example that I gave you on the quiz, and then we proceed. So a summary. So suppose we have a quantity that changes by the same percent rate every unit of time. That's crucial, by the same percent, not by the same amount. Every year it changed by the same percent. And let f be the function that associate to each time t the value of this quantity at this time. So f could be population, which is the example I took. F could be the amount of caffeine in our body, which is another example I will probably give you now or your exam. So things change by the same percent. Usually when you take medication, medication is absorbed by your body, of course, and is eliminated by the same percent every hour. So that's another example of a lot of time viruses grow exponentially, like the virus we're struggling with from. At some point, even now, right now, we're going through an exponential growth, not definitely a linear growth. So let f be the function that assigns to each time t the value of this quantity at this time. So we have something that's grow by the same percent. Then what's the formula? F has an exponential form, a b to the t. A, the initial value. B, that's the growth factor, is 1 plus the growth rate. Now, a word about the growth rate. If the quantity increases, the growth rate is positive, and that's make the B bigger than 1 because we're adding something to it. If the quantity decreases, the percent growth rate is negative. So when the population decreased by 3%, we say that the percent growth rate is minus 3%. In this case, your B, it's 1 minus something, it's going to become less than 1. Idea? So that's really what's happening with a percent growth rate. Any questions before I move on? It's your chance to ask me questions. Is that clear? It has to be very clear because it's a very important idea. Very nice. Now, I'll go back to your quiz number 2, and I go through problem number 3 that I knew some of you struggled with it. So that's my scenario. In January 2005, which is the correct numbers, the population in California was 36.8 million. Okay, that's the population. And it's growing at an annual rate of 0.9%. It means every year it's increased by 0.9% of the year before it. That's really what it means. And my question is, let f of t be the population after 2005. Find a formula for f of t. So that's a typical exponential growth. That's not linear, that's an exponential growth. Because as we saw a minute ago. So f of t here is exponential. So it has the form a times b to the power t. That's the form. Now, every piece by itself. The a is the initial value. Now, because I used million as a unit, a lot of you, and I no problem with that, they wrote 36.8000000. They rewrote it. You don't have to. You can keep this 36.8 and keep in your mind that the unit is million. So this makes the math much easier. So A is 36. Now what's the B? The B is 1 plus the growth rate. 1 plus. It means this is the percent growth rate. It's by how much percent is increasing. Now my growth rate here is 0.9%. Okay, and here we had some issue with that. 0.9% means 0.9 divided by 100. So basically you pick up your calculator and this is gonna give you 0.009. That's the growth rate. The B is not the growth rate. The B is 1 plus the growth rate, 0.9. Okay, so every year the population is 100% of what it was plus 0.9% of what it was. That's really where this is really coming from. And this is 1.009. That's my B. Now finally, what's my f of t? My f of t is 36.8 times 1.009 to the power t. Some of you multiplied by t. So be very careful what the formula is. This is a multiplication right there. And this is to the power t. T is a power, is not, you multiply. Now, population 2050. Now, that's, at this stage, it's become easy. Initially, it's 2005. That's t equal to 0. So t equal to 0. correspond to 2005. So 2050, and everybody has no issue with that, is t equal 45. So basically, okay, so I don't understand the comment. Yeah, it's 0.009. That's not zero. That's not zero. I mean, the population, if it grows very fast, it will explode. So that's the growth. So now F at 45. So that's 36.8 times. Remember, that's a product. That's the year, and that's 1.009. And now if you compute that, we almost got like 55 million. Okay, that's a good estimate. So it definitely grew. So first of all, it was 36.8. It grew to 5 million, even though it's a very, very, very small number, but it's growing. And that's how it was in 55 years. Okay, so that's the question that we had on the quiz. Another very similar problem. Let us say in a certain town, the population is 2 million and it's decreasing by 2%. Find the formula for f of t. I gave you 2 minutes to give me the formula. Get going. All of you, you have 2 minutes to do it, not more, because I have a lot to wrap up for today. So always you start, that's exponential, because by the same percent, and then you figure out your A and you figure out your B very clearly, okay? That's for the first problem. Now I'm in example 2, so. As I said, you don't have to write this. You can write 36.8 and then the unit is million. This will save you a lot of writing all those zeros. So keep your mind here. I got 55, but then I write for this million. So I don't have really to worry about writing all those zeros. Be careful, be careful, be careful. Be careful, be careful. No, 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 it's not a plus. Be careful. It's not a plus. Okay, it's not a plus. Be very careful. Exponential is initial times. That's a product. I want the formula very, okay. All right, now we're doing better. Now we're doing better. Okay, so A is the initial value. You can write 2 million or you can write 2. Do not be afraid of that. Now B. B is, now we have to be very careful. It's 1 plus the growth rate. That's really the formula for it. But my growth rate here, be extremely careful, is decreasing. So it's minus 2%. It means it's minus 2 over 100. It means it's minus 0.02. That's my growth rate. It's negative. So my B is 1 minus 0.02, which is 0.98. And it makes sense. The population's losing 2% every year. It means every year it's 98%.
CH.
Ajá.
Okay. It means it's losing 2%. Means every year the population is 98% of what it was. 98% of what it was. That's really a good way to think about it. So now my f of t is 2, but the unit of f is million. So you can keep 2 here. You keep in mind the unit is million. Times every year we multiply by 0.98. And that's the formula for the population. So you have to be very careful whether it's an increase or a decrease. That's important. And know the formula exactly. No gimmick. All right. My last example with this idea is the following. I'm switching a little bit gear. Not switching, but this time I am giving you the formula. And I want you to find initial value, the growth factor, and the growth rate. So imagine the scenario of telling you, okay, a certain quantity is changing according to the following formula, which is typical exponential. Initial, growth factor, growth rate. So initial, growth factor, growth rate. Okay, 1 minute, I want the answers. Initial value, quickly. Oh, sorry. Okay, it means, if you ever forget, it means the value at 0. That's the initial value. That's 4. The growth factor. The growth factor is the B. That's the growth factor. That's the 1.4. Now, the growth rate. The growth rate. The growth factor is 1 plus the growth rate. Okay, exactly. It means the growth rate is basically in this problem, which is 0.4 or 40%. It means when you guys look at this function, you should think that's a quantity which is starting at 4 and is growing by 40% every unit of time, whatever the unit of time is. So that's represent this type of growth. Okay, the second one, again, initial. What happened now? Okay, sorry. Initial, growth factor, growth rate. Okay, initial 5, growth factor is this one, 0.92. Now the growth rate. The growth rate. To find the growth rate, the growth factor is 1 plus the growth rate. So the growth rate is going to be 0.92 if you want minus 1. Okay, which is minus 0.08. And it makes sense here. This is a quantity that is decreasing, and it's every year, it's 92% of what it was. It's actually losing 8% every year. So the growth rate is minus 8%. Okay, and we can use the formula to figure it out, but the minus tells me that it's decreasing by 8%. Okay, so this is application of exponential. This is exactly, how exponential function occur. They occur when things grow by the same percent. That's how we find their formula. And if a formula is given to us, that's how we read the information from. Okay. Now, part 2 is, again, something Professor Sita talked about. Suppose we have an exponential function. So you're told it's exponential. But, okay. But this time, you're not given the growth rate or anything. What you're given are 2 points on the exponential function, and you need to find a formula for it. So I'm going to repeat this idea a little bit. So it's again section 3.1, and the idea is how to find a formula. For an exponential function from 2 data points. From 2 data points. Okay, so sometimes people know it's exponential. They actually don't know what the rate is, but they have, data point that really guide them. So the question is, how can we find a formula from that? Now, remember that for linear function, let me kind of take it. Suppose we have a linear, means linear, a function whose graph is a line. If I give you two data points, means if I give you 2 points, whatever, 1, 5, 6, 8, whatever number I'm writing. So this is a linear function. It means it's mx plus b. And I tell you find a formula for f. We learned how to do that. Okay, we find the slope and then use the slope intercept form or point slope form, and we find a formula. So from 2 data points, I was able to find a formula. Now we're going to do the same, but now instead of working with linear, we're going to have an exponential function. Now, a comment about, before I go on, the graph of the exponential. Even though I will talk a little bit more about it later, but the graph of exponential function is definitely, the exponential function is not a line, and we realize the graph really actually go like that. If we have a growth, if it's increasing, and it's decreasing, it's go like this. So that's how the graph of the exponential really is gonna go. So this is the graph. If we have increase, it means my b is bigger than 1. And this is the graph if this b is less than 1. Because when b is less than 1, we actually have a decay. When b bigger than 1, we have a growth. Okay, so that's how the graph look like. I will come back to the graph later on in more details. So now I'm going to put the following problem. Okay, suppose I have f of x an exponential function. So I'm already giving you stuff. I'm already telling you that's exponential, an exponential function. And below are some values for f. Okay, so this is the value. 2 values, x, f of x. At 0, I'm going to give, and at 2, 12. Okay, so basically what I have in mind is this function, an exponential function. At 0, we have the value 3. And at 2, we have the value 12. So these are the 2 points. And that's exponential, so it's kind of curving like this. And it usually goes like that, it dies out here. And that's the part I will explain later. And the question is, find a formula for f. Okay, so that's really my problem here. So it's exponential, and I have 2 data points. I want a formula. It means I want a way to find that, if it takes this value at 0, this value at 2, what does it take at 3, for example? If I know a formula, I know what it takes at every value I want. Right. It's exponential. Like when you say it's linear, it's mx plus b. Exponential, it means I know that my function takes the value a times b to the x. That's crucial. That's the formula. What does it mean to find the formula? Finding the formula means I need to find a and I need to find b. Okay, so the question now is like in linear. When I said linear, mx plus b, when we find the formula, we find the m, the 2 unknown, m and b. And now it's the same thing. I need to find a and b. Now, my first scenario is easy because I gave you the value at 0. The second scenario, I'm going to remove that scenario. So let us see how we're going to do that. Okay, so I'll rewrite the given. So that's the given. X, f of x, at 0, 3, and at 2, 12. Okay, and my function f of x now is a, that's the 4 because it's exponential. Otherwise, this is not correct. So how can I find a and the b? Okay. All right. Is anything given? Let's see. Let us read this data. What does this data read? This data read the following. At 0, the function takes the value 3. Be careful how I'm going to do that. It means if I plug in 0 for x, my output is 3. So it means if I take a times b to the 0, I get 3. But this gives me immediately a of the back, which is we knew because a is the initial value. I got a equal to 3. Okay? Now, what's my other data tells me? At 2, my output is 12. Okay? What does it mean? It means that if I plug in 2 for x, my output is equal to 12. Are you with me what I'm doing? My goal is to find a and b. I know a already because I started with a simple scenario. But a is equal to 3, means I know this piece. So this is going to give me that 3 times b squared equal to 12. And now I solve for b. It means b squared equal 12 over 3, which is equal to 4. Now my b is always positive. So this is going to give me b is equal to 2. And now I have my function that fit the data. So f of x equal 3 times b to the power x. And that, and that's the formula for my exponential function. That's a multiplication. That's multiply times 2 to the x. Okay? Now let us verify that the formula I have fit my data at least. Just now let us check. Let me check. That's exponential, that's the 4, and does it fit my data? If I put 0 here, with 3 times to the 0, it's a 3. It means this is checked out, correct. If I put 2 here, I will have 3 times 2 squared, which is 4. 3 times 4 is equal to 12. So it definitely, my formula fit my data, and that's an exponential function. All right, so how to find a formula if you have 2 data points? My first example, first exponential, it means that's the 4. And I have 2 data points. I want to find the general formula. In this problem, I made it a bit easier. I gave you the initial value. In the following problem, I will not give you the initial value. So, but the idea is that if f takes 0 to 3, it means if I plug in 0 here, I'm going to get a times b 0 equal 3. And because I gave you an easy situation, a equal to 3, then I use my second point, f of 2 equal 12. Means if I plug in a, b squared here, I should get 12. But in this problem, I already have a, so I can isolate my b squared, and I get b equal to 2, and I get my formula. Okay, let's do another problem where I will not give you the a of the back, but I have to give you, of course, 2 data points. I need 2 data points because I have 2 unknown to figure out. So problem number 2. Here we are. So example number 2. Again, this is another problem where I'm not giving you the percent rate. I'm giving you 2 data points, and we need to find the formula. So my problem is some values of an exponential function are given. are given. Find a formula for f of x. Okay, so these are my values. X, f of x. And at 1, I have the value 3. And at 3, I have the value 12. Okay, and my question is find a formula. All right, so exponential means it has the form a times b to the x. And the question is, I need to find the a and find the b. So let's read this. This tells me that my function f sends 1 to 3. Let's make use of that. F sent 1 to 3. And it sent 3 to 12. What does the first one tell me? What does it mean f of 1? What's the equation that this will give me? So I need to find a and b. Okay. So that's really what the problem is. I have 2 unknowns, and I have kind of 2 equations that's going to find me 2 unknowns. So what's the first equation? F of 1 equals 3. What's the equation that this would give me? Write it up. How do I read f of 1 equal to 3? It means what? It means if I take a times b to the power 1, this should give me 3. That's what it means. If I plug in 1 here, I get 3. F of 3 is 12. Tells me what? It means if I take a times b to the power 3, I should get 12. That's how I read the data. That's exactly how I read. And now the question is, I want the a and I want the b. So the way you think about it, I have 2 equations with 2 unknowns, a and b. And the question is how to find them. Okay. You guys remember how Professor Susita did that for you? Anyone? Because there is a small trick that we use. Anybody remember it? Anybody there? Okay. If you guys remember it, no problem, I will do it. Okay, the way we do that, well, listen carefully how we're gonna do it. The way we do it is that we divide one by the other. Okay, so what we're gonna do is say, okay, if this is equal to that, I'm gonna take the ratio. Be very careful how I'm gonna do that. This divided by that. And I try to take the highest exponent in the top. A times B, look what I did, equal to. What's AB to the power 3? That's 12 over 3. That's the trick. That's really the trick. That's really the hard part. Now, what's the benefit of this? What's the benefit? Help me out. What's the benefit of doing this trick that you're learning? Remember, I need to find A and B. Means I need to find a way to isolate one of them to solve for it. When I take this, no, you cannot solve for A. What can you do? A times B3 over A times B, we can simplify the A now. Right, we can cancel out the A. And this will give me B to the 3 over B equal to 4. All right, so the benefit of dividing them helped me to cancel out the A and then basically isolate the B. Now, as I told you, always take the highest exponent in the top. It will make math much easier. Now, B to the 3 divided by B will leave me B squared. Right now, we are in a simple scenario. equal to 4. Okay, so this is gonna give me that the b will be the square root of that. B is equal to 2. Now I have the b part. I have the b. Now I need the a. Okay, so now we need a. It's like solving. We're really solving for 2 equations with 2 unknown. How do I find my a? Stay with me and you guys will get it. How do I need my a? How do I get my a? Remember, I have 2 equations. The a and the b have to satisfy both of them. I have b. To find a, I can pick any of those and solve for a. You can either pick this one or pick this one. I don't really care. So we need a. So let us remember, recall that a times b is equal to 3 because f of 1 is equal to 3. And now I plug in b for 2. But b is 2. So this is going to give me a times 2 equal to 3. And this will give me a equal to 3/2. So that's really the trick in this problem. So now I have my function. So that's my function. So now f of x, if I have 2 data points, I have f of x equal to 3/2, that's my a, times 2 to the power x. And that's really my function. Now I can check if my answers are correct. So that's the form of an exponential. So let us check that my answers are correct. So let me check. So what do I mean by check? So my formula was f of x equal 3/2 times 2 to the x. So let us check. Does it satisfy? Does my formula fit into the data? Okay, f of 1 is 3/2 times 2 to the power 1 equal to 3. So it satisfies this condition. Does it satisfy the other one? What is f of 3? According to my formula, it's 3/2 2 to the power 3. Now 2 to the power 3 is 8. So this is going to give me, this and this give me 4. That's give me 12. This data is satisfied. So now I have an exponential function that satisfies both data points. Okay. All right, I will do one more problem along those lines. And this will, I hope, wrap up what Professor Susita did for you. So problem number 2. And this one, I want you to work it out. The same type of question. Let f of x be an exponential function. And the word exponential is crucial. If I don't write exponential, you tell me, well, we have no idea what we have to do. And these are some data points. X, f of x. Okay, at 2, it's 4. At 5, it's 13.5. Or I could have given you the graph. Instead of giving you the function, I can give you a graph. For example, I can give you the graph. I tell you these are 2 points on the graph of the exponential. 2, 4, and let us say 5, 13.5. And the question is, find a formula. Okay. All right, I want you to start it. It's easy for me to show you. Get started. Get started and slowly you figure it out. So I have enough time to give you 5 minutes almost, 4 minutes for you to get started in front of you. And then we work it together. See if you guys got it clearly. If anybody found any of the A or B, just put it up. So help me out. Anyone? Anything? How do we know which exponent to use? Okay. We go after here. Watch what we're doing. The function should take the input of 2 to an output of 4. It means that 2 is the input. It means if I plug in 2 for x, I should get 4. Is this the question? So what should be here? Yes, what should be here? It means this is the exponent. That's the input. B to the power 5. That should give me an output of 13.5. That has to be very well understood. That's really what this means. And now the way we look at the problem is that you have 2 equations in A and B and 2 unknowns, and you have to solve them. That's really what it is. What is the problem is. Now there are different ways of solving them. Last year my student came up with a different way than what I'm doing this year. But now we're doing this way. They came up with their own way and we kept going with whatever approach they did. But the main idea is that we have 2 equations, we have 2 unknowns, we have to find them. That's really what it is. Okay, so one trick, I think I'm starting to getting good answers. One trick is divide this by that. In other words, take, and I use the highest exponent on the top simply because the math is easier. It doesn't really matter, but the math is easier. What matter is AB to the 5, that's the 13.5. That's what matters. And this AB squared equal to 4. The trick here is that because I can simplify by A, so I can isolate one of them. So this will give me B5 over B squared is divided by 4. Now, what's B5 over B squared? Now remember, that's the law of exponent. The way we divide exponent is it's 5 minus 2, which is B to the power 3. Or you think about it, B5 is B times B times B times B times B 5 times. You divide it by 2 B's, you're left with 3 B's. That's why we take them away. So this will give me B to the power 3 equal to that over 4. Okay. So now I need A is, I will check it, Kaylee, give me a second. I don't know what I got. So that's B3. So now I need the B. I have to get rid of the, so B is going to be the cubic root of 13.5 over 4. And now I pick up my calculator and I compute that. So it's 13.5, and my calculator is off. It's 13.5 divided by 4. It's the cubic root. The cubic root, it means to the power 1/3. And I have a syntax error. So it is 13.5 divided by 4. The cubic root, it means to the power 1/3. third, which give me exactly 1.5. So that's how I entered it, exactly 1.5. Now I have my B. Now I need my A. So let me check if you guys have the correct answer. That's the B. Now A, I can use either this equation or that to get my A. So let me use this one. So here, we have to recall that A times B squared equal to 4. But B is 1.5. So it means A times 1.5 squared is equal to 4. With me? So what's my A? I need to divide by that both sides. So A is 4 divided by 1.5 squared. Okay? Now, whether you use this equation or that, you will get exactly the same answer. So I used the first one because the smaller power, that's it. So AB squared is 4, but B is 1.5. So I plugged in 1.5 for B. So that's 1.5 squared. Now to isolate A, I divide by this. So this will give me A equal, and okay, let me do that. It's 4, okay, divided by 1.5 squared. So I'm getting almost 1.78. So I'm gonna round it to 1.78. And my function, so there is a little bit of rounding. Actually, you can, so my function now is, you can give me two answers. Either you can tell me 1.78 times 1.5 to the power x, that's acceptable, or, which is actually a more accurate answer, you can just keep it this way, times 1.5 to the power x. Okay, and that's really how we can find a formula for exponential if I don't have the percent rate, I just have the data point. Okay, so let us summarize. If I have a function, it's growing by the same percent or decreasing by the same percent, then the formula, we figured it out. Then the formula would be initial times 1 plus the growth factor to the power t. If I know, the growth rate. So if I know the growth rate, I know how to deal with the formula. If I don't know the growth rate, but I know that the growth is exponential and I know two data points, and to find the formula, then we have to play this little game here to be able to find the formula for the exponential function. All right. So for Thursday, I'm going to assign again problem from section 3.1. And I want you to do them for sure, 100%. And you ask me question next time. On Thursday, I will contrast, and I know also Professor Sita talked about that, but I will contrast again linear behavior versus exponential behavior, which is very important for us to know. And we do the graph of exponential, and this will wrap up exponential for us. All right. This being said, there is one thing I would like to discuss with you. And no, there will not be Moodle homework. I just want you to do the homework from the, from the book, the one I will assign this time. The Moodle still have only one homework. So I'm not really worried about it. So we're done with Moodle, but you have to do, unless you want me to, I can give them to you. So we're done with Moodle. What I want you to do is to do the practice, because Moodle only have one homework to go. Then that's it. There is nothing else after that. So don't worry about Moodle anymore. The thing I would like to discuss with you is your exam number 2, because this has been postponed, of course. everything is. Exam number 2. Now I tell you what my idea is. If you have objection, you have to object right now. So my idea is that it's going to be definitely next Tuesday. Okay. One scenario is, if not, I'll have to change it. One scenario is the following. We have regular class where you can ask any questions. So regular class, you ask any questions about the review, because the review will be on Brightspace. Any questions? Okay. And the class usually end at what time? 1:45. I can give you the exam. I can open the exam basically after class, like at 2 p.m. And I can give you a lot of time. And I can close the exam in the evening around 9 p.m. So you have plenty of time to do it. Okay, so that's one scenario. However, if you have any student have objection on that, I will have to give you the exam during my time. So any student have objection with this. Any student this time will conflict with them. I want answers right now on chat. So we will have class as regular. You ask me any questions you want about the review. Then after class, I will open it at 2. I'll give you time till 9, and then you have plenty of time really to do the exam. But if there is objection, it means it doesn't work for you. I cannot do that. Okay, so those who are objecting, anybody is objecting for that? Okay, I'll email again with that. So that's really, so then I'm gonna settle on this scenario. Settle on this scenario. So we're working on the review. I will put it up very soon. You guys work on it as usual. Next, everything I will cover on Thursday will be on your exam. Everything. Tuesday, you guys have done the review. You have questions. You're gonna have 1 hour and 15. I answer every questions you have. And then I'll open your exam at 2. I close it at 9. Is that fine? Okay, and Thursday, as usual, you guys will have a short a quiz as usual, and make sure you do the homework well, so you guys do it. Any questions before I let go? Okay, bye-bye, guys. See you next Thursday.